In maths, we always want to draw a picture to help us solve our problem and get all our information organised. And probability is no different. And one of the most important diagrams in probability is the tree diagram. So in this instance, we're tossing a coin and then spinning the spinner. So when we toss the coin, our options are head and tail. And when we spin the spinner, there are three options. Assuming all those areas are equal, we've got blue, yellow and red, or blue, yellow and red. So the first thing we're going to do is toss the coin. So options are head and tail, and we know that if it's a fair coin, the probability of a head is a half as it is for a tail. And if those areas are equal, we know the probability of landing on the blue is 1/3. Yellow is also 1/3, as is the red. So with our tree diagram, a couple of things to note, that every single one of these sideways V's, both of those probabilities must add to 1. And if we have 3, like we do in this case, we don't often see a tree diagram with 3 different outcomes, but those 3 probabilities must also add to 1. So when we have this tree diagram, if we want to see what all the different options are for the sample space, we could toss a head and then land on blue. We could do the same thing with a head and land on yellow, or head and land on red. Or if we tossed a tail, we could have tail blue, tail yellow, and tail red. And to determine the probability of a head and then blue, we multiply along the branches. So the probability of tossing a head and then landing on blue would be a half times 1/3, which would equal 1/6. Now this is a more regular type of example where we would use a tree diagram. We're tossing that fair coin 3 times. So each one of these columns corresponds to one toss of the coin. And if we wanted to know the probability of obtaining exactly 2 heads, so when we have a look at our options, 2 heads could come from this one, and also this one. So there are 3 branches where you could get 2 heads and a tail. So because the probability is the same for a head and a tail, all of those probabilities are the same. Therefore, all the branches will end up having the same probability. It's all a half times a half times a half. So in this instance, because the probability of each one of these branches, so if I were to go along, so this branch here has a probability of 1 in 8, and it would be the same for every single one of the branches. So because there are 3 branches out of a total of 8, we can just quickly and easily say that for question A, if we want to know the probability of 2 heads, there are 3 different branches which would give us that, and that would mean the probability is 3 in 8. When we look at part B, where it says 3 heads or 3 tails, also 3 heads is head, 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 and 3 tails is tail, tail, tail. So there are 2 branches that would give us that probability. So 2 out of 8, and of course we would never leave a fraction unsimplified. That means 1 in 4.